Assalamualaikum and hi everyone. Our group will present our experiment lab 2, which is from ECE521. Okay, so this is our team. First, we have Is Alif Atimi bin Muhammad Mumtaz. Second, Dedish Aiman bin Muhammad Ezrin. And the third one is Amir Razin bin Muhammad Azhar. Okay, so for question 3, write and execute an assembly program that turns on LED 0 to LED 7 connected at port PB0 to PB7 with three different patterns and condition of switches as shown in table. So when SW1 is pressed, LED1, LED3, LED4 and LED6 will turn on. When SW0 is pressed, LED 0, LED 2, LED 5 and LED 7 will turn on. So when both switch press, LED 0, LED 1, LED 6 and LED 7 will turn on. So at below, we'll see that the circuit diagram for this question. So as you can see, input is connected to the PC1 and PC13. So for the output, LED will be connected from PB0 until PB7. So input is active low while output is active high. For this section, I will explain about the flowchart and the circuit connection. On the left side, you can see that the flowchart of this program based on the question. So it have a three different option. For the first one is SW1 and SW1 and SW0 press. For the second one, SW1 only press, and the third one SW0 only press. When both switch are not pressed, it will remain the LED do not turn off. So at the right side, you can see that the real connection of microcontroller, which is that is STM32 Nucleo to breadboard that contain LED, resistor, and two push button.
So I will explain the pre-lab. RCC AHB1ENR have two ports, which is port B and port C. We write down the value 1 to port B and value 1 to port C. So we convert the binary number to decimal number, and RCC AHB1ENR is equal to 2 and 4. Moving to GPIOB model for output, we have 7 output pin, which is PB0 until PB7. First of all, I will explain the BIC, which is bit clear. Set the pin value with 1 for PB0 until PB7. So for BIC, we can get the value is 0000FFFF. For ORR is bit set. Set the pin value with 0101 from PB0 until PB7. For ORR, we can get the value is 00005555. Next, GPIOC model for input. We have used two input pin, which is PC1 and PC30. For BIC, we set the value with 11 for PC1 and PC30. So BIC value we can get is 0C00000C. Okay, for GPIOA IDR, for masking is used to select only one input to enter. So we can set the value 1 for pin that we want to use is PC1 or PC30. Set the value 1 to PC1 and PC30, and masking we can get value is 00002002. For switch, we know that the connection is active low, so the value 0 is used for on and value 1 is used for off. For this condition, switch 1 is pressed, and we should set the PC30 with 0 value and PC1 with 1 value. So we can get the value of switch 1 press is 00000002. For the net condition is when the switch 0 is pressed, we set the 0 value for PC1 for on condition and value 1 for off condition at PC30. So when switch 0 is pressed, the value is 00002000. And the last condition is when the both switch 1 and switch 0 is pressed, set the both value with 0 and we can get the value of the both button press is 00000000 and 00. For GPIO ODR, for connection output is active high because the LED is connecting to the ground. So active high, we can set the value 1 for on and value 0 for off. For pattern 1, when switch 1 is pressed, the LED 1, 3, 4 and 6 will on. So we set value 1 for LED 1, LED 3, 4 and 6. So for pattern 1, we can get the value is 00000058. Moving to the next pattern. For pattern 2 is switch 0 is pressed and LED 0, 2, 5 and 7 will on. Set the value 1 for LED 0, 2, 5 and 7. We can get the value for pattern 2 is 000000A5. For the last pattern is when the both buttons are pressed, the LED 0, 1, 6 and 7 will on. Set the value 1 for LED 0, 1, 6 and 7. So the value of the last pattern is 00000006 C3. So that's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zeni Shaiman and I will proceed my presentation. So for this slide, shows an ARM assembly program used to configure and control GPIO ports on an STM32 microcontroller. At the beginning of the code, we define the program structure, which is area program code read only defines a code section in memory, export main makes the main function visible to the linker, and also entry marks the entry point of the program. Next, we define the memory address of important hardware register, which is RCCA-HB1ENR, which is used to enable the clock for GPIO ports. GPIO-B model controls the mode of GPIO port B pins, GPIO-B ODR, output data register for port B, and also GPIO-C model and GPIO-C IDR used for input configuration and reading input from port C. Using EQU allow us to assign readable name to hardware addresses. Before using any GPIO port, its clock must be enabled. The code load the RCC register address into R4, reads the current value into R5, uses ORR to enable GPIO-B clock and GPIO-C clock. Right. This step is essential, otherwise the GPIO port will not function. For this section, configures GPIO port B as output. Clears previous mode setting using BIC, set the required bit using ORR, configures pin PBO and PB7 as output pin. This pin can later be used to control LED or other output devices. Overall, the program prepares GPIO-B for output and GPIO-C for input by enabling clocks and configuring pin modes. So for this section, configures GPIO port C as input. The address of GPIO-C model is loaded into register R4. The current register value is loaded into R5. A bit mask is loaded into R6. The BIC instruction clears specific bits. This clears the mode bits for PC1 and PC13, setting both pin as input pins. The update value is written back using STR. These pins are typically connected to push button or switches. Next one is the program enter an infinite loop labeled loop. The input data register GPIOC IDR is loaded. The current input value is read into R0. A mask is applied using N to extract only PC1 and PC13. This allows the program to read the button state without interference from other pins. The program then compares the input value to detect different button press condition. If both buttons are pressed, the program branches to the both press routine. If only switch 1 is pressed, the program jump to the SW1 press routine. If only switch 2 is pressed, the program jump to the switch 2 press routine. If none of the condition are met, the program assumes no button is pressed. The program branches to LED off. This turn off the LED output. This code continuously reads input from GPIOC, check different button press combination, and control the output behavior accordingly. So for the last section of the code controls the LEDs connected to GPIO port B based on different button press condition. When switch 1 is pressed, the program executes the SW1 press routine. The address of GPIO B ODR is loaded into R4. A value 0600005A is loaded into R5. This value represents pattern 1 for the LEDs. The value is returned to the output data register. The program branches back to the main loop. As a result, a specific LED pattern is displayed. When switch 2 is pressed, the program executes the SW2 press routine. GPIOB ODR is loaded again. A different value is loaded. This creates a different LED pattern called pattern 2. The pattern is returned to the GPIO output. The program returns to the loop. If both switches are pressed at the same time, the program jumps to both press. The GPIO output register is loaded. The value 0x000C3 is returned. This turns on a specific combination of LED. The program looks back to check input again. If no switch is pressed, the program executes the LED off routine. The output register is cleared by writing 0x00. All LED are turned off. The program returns to the main loop, and that's all. So for the conclusion, this part of the code controls different LED pattern of GPIOB based on the input from the two switches on GPIOC. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So basically this is our circuit that we have made. So for this one is button of SW0 and this is the button for SW1. So basically when we push the button of SW0, we can see that the LED 0, 2, 5 and 7 will turn on. When we push the button SW1, we can see that LED of 1, 3, 4, 6 will turn on, and when we push both of the button, you can see that the LED of 0, 1, 6, 7 will turn on.